My dear students, welcome back to our channel. In this video, I will be explaining the MBA second semester subject Business Research Methods as prescribed by Osmania University, Palamuru University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 4 first important short question is: what is hypothesis? A hypothesis is a simple assumption or guess that a researcher makes before starting a study. It is like a possible answer to a research question, which will later be tested with data. In other words, a hypothesis is a statement that can be proved true or false using research and statistics. It gives a clear direction to the study. Example: suppose a researcher wants to know whether online classes are more effective than classroom teaching. The hypothesis may be: students who attend online classes score higher than those in traditional classes. Here, the researcher will collect data, students' marks, and test whether the hypothesis is correct. Key points to remember: hypothesis is equal to assumption or prediction. Must be clear, specific, and testable. Helps researchers stay focused. Can be accepted or rejected after analysis. In short, a hypothesis is like a starting point of research, guiding the way to the final conclusion. Next important short question is: 2. Type I and Type 2 errors. When researchers test a hypothesis, sometimes mistakes happen in decision-making. These mistakes are called Type I and Type 2 errors. Type I error. This happens when the researcher rejects a true hypothesis. Simply, it means declaring something is there when it is not. Example: a teacher thinks a student cheated in an exam and punishes him, but in reality, the student did not cheat. Type 2 error. This happens when the researcher accepts a false hypothesis. Simply, it means failing to see something that actually exists. Example: a doctor says a patient is healthy, but in reality, the patient has a disease. Easy tip to remember: Type I error is equal to false alarm, thinking something happened when it didn't. Type 2 error is equal to missed detection, failing to see what really happened. Both errors are important in research because they affect the accuracy and reliability of results. Next important short question is: 3. Small samples and large samples. In research, the sample size, number of observations, is very important for analysis. Based on size, samples are divided into small and large. Small samples. A sample is called small when the number of observations is less than 30. Small samples are often used in pilot studies or when population size is small. Statistical tests like t-test are used for analysis. Example: if a teacher studies the exam performance of 20 students in a class, it is a small sample. Large samples. A sample is called large when the number of observations is 30 or more. Large samples give more reliable and accurate results. Statistical tests like Z-test and Gsquare are commonly used. Example: if a researcher studies the feedback of 200 customers about a new product, it is a large sample. Easy tip to remember: 30 is equal to small, use t-test. Greater than or equal to 30 is equal to large, use Z-test Gsquare. Next important short question is: 4. McKermer Test. The McKermer Test is a statistical test used when we want to check if there is a change in responses of the same group of people before and after some treatment or event. It is mainly used for yes-no or success-failure type data. Key idea: It is applied to paired data, same people tested twice. It tells us if the change is significant or just by chance. Example. Imagine 50 students are asked before a workshop, "Do you like online classes?" Before, 20 said yes, 30 said no. After the workshop, 35 said yes, 15 said no. The McKermer test helps to check if the workshop really changed the opinions of students or if the difference is just random. Easy tip to remember. Think of McKermer test as a before versus after opinion test for the same people with yes-no answers. Next important short question is 5. ANOVA analysis of variance. ANOVA is a statistical test used to compare the average, mean, values of 3 or more groups to check if they are really different from each other or not. Key idea. If we want to compare only two groups, we use a t-test. But when there are 3 or more groups, ANOVA is the best tool. It tells us whether differences in averages are significant or just due to chance. Example. A teacher wants to see if 3 different teaching methods, lecture, group discussion, and online learning, affect student marks differently. Group 1, lecture average is equal to 70. Group 2, discussion average is equal to 78. Group 3, online average is equal to 75. ANOVA helps the teacher check whether these differences are real or just random variation. Easy tip to remember. ANOVA is equal to analysis of variance, but actually compares means of many groups. Think t-test for 2, ANOVA for 3 or more. Next important short question is 6. Factor analysis, discriminant analysis, cluster analysis. Factor analysis, discriminant analysis, and cluster analysis. These are advanced statistical techniques used in research to understand data better. 1. Factor analysis. Purpose: to reduce many variables into fewer factors. Example: a survey has 20 questions on student satisfaction. Factor analysis may group them into 3 main factors like teaching quality, facilities, and support services. 2. Discriminant analysis. Purpose: to classify people or objects into groups based on their characteristics. Example: a bank uses discriminant analysis to decide whether a loan applicant should be classified as low risk or high risk based on age, income, and credit score. 3. Cluster analysis. Purpose: to group people or things into clusters so that items in the same group are similar. Example: a company may group customers into budget buyers, premium buyers, and occasional buyers for better marketing. Easy tip to remember. Factor is equal to reduce variables. Discriminant is equal to classify into groups. Cluster is equal to group based on similarity. Next unit 4. Long questions. First important long question is 1. Parametric and non-parametric tests. In research, after collecting data, we need to test whether our assumptions or ideas are correct. For this, we use statistical tests. These tests are mainly divided into 2 types, parametric and non-parametric. Parametric tests. These tests are used when data follows certain rules, like normal distribution, bell curve shape. They work with numerical data such as marks, income, height, weight, etc. They assume that the data has a mean, variance, and standard deviation. Examples: t-test, z-test, f-test, ANOVA. Example for students: if we want to test whether the average marks of MBA students in Hyderabad is 60, we can use a t-test because marks are numerical and follow a distribution. Non-parametric tests. These tests are used when data does not follow strict rules or is in the form of ranks, categories, or yes-no answers. They are more flexible and can be used for small samples. They do not assume normal distribution. Examples: Gsquare Test, Whitney Test, Kruskal-Wallis Test. Example for students: if we want to test whether boys and girls prefer online classes differently, yes-no responses, we use the Gsquare Test because the data is categorical, not numerical. Key differences, easy to remember. Feature: parametric tests, non-parametric tests. Type of data: numerical, marks, income, categorical rank, yes-no, ranks. Assumptions: strict, normal distribution, no strict assumptions. Sample size: works best for large samples, works well for small samples. Examples: t-test, ANOVA, z-test, Gsquare, Whitney, Kruskal-Wallis. Quick tip to remember. Parametric: para is equal to pattern, needs pattern in data, normal distribution. Non-parametric: no pattern, works even without strict rules. In short, use parametric tests when data is numerical and normally distributed. Use non-parametric tests when data is categorical, ranked, or doesn't follow rules. Next important long question is: 2. Gsquare Test. In research, we often want to know if there is a relationship between two things. For example, do boys and girls have different preferences for online versus offline classes? To check such relationships, we use the Gsquare Test. What is Gsquare Test? The Gsquare Test is a non-parametric statistical test. It is used when data is in the form of categories, like yes-no, male-female, agree-disagree. It checks whether the difference between actual data, observed, and expected data is significant or just by chance. In simple words, it tells us if there is a real connection between two factors, or if the result is just random. Types of Gsquare tests. 1. Gsquare test of independence, to check if two factors are related. Example: gender and preference for online classes. 2. Gsquare goodness of fit test, to check if the data fits a particular distribution. Example: do students equally like cricket, football, and badminton? Example for students. Suppose we surveyed 100 students about their preference for class type. Preference: boys, girls. Online classes 30-50. Offline classes 20-0-0. Observed data, the actual numbers we collected. Expected data: if there was no relationship, we would expect similar proportions of boys and girls in both choices. The Gsquare test compares these numbers. If the test result shows a significant difference, we can say, yes, boys and girls really have different preferences. If not, then the difference is just by chance. Why is it important? Helps teachers, managers, and researchers understand behavior patterns. Useful in marketing, education, psychology, and social sciences. Quick tip to remember. Think of Gsquare as checking a square box table, rows and columns of data. It is mainly used when data is categorical. In short, the Gsquare test is a simple tool to check if two factors are related, like gender and preference. It is easy, flexible, and widely used in research when dealing with yes-no or category-type data. Next important long question is: 3. One-way and two-way analysis. In research, when we want to compare average values, means, of different groups, we use analysis of variance, ANOVA. It helps us check whether the differences between group means are real or just by chance. One-way ANOVA. meaning used when we compare one factor, independent variable, across two or more groups. Example, a teacher wants to check if students' marks are different based on teaching method, lecture, online, group discussion. Here, the factor is equal to teaching method, 1 factor. Groups is equal to 3 teaching methods. If one-way ANOVA shows a significant result, it means at least one teaching method gives different average marks compared to others. Use when there is only one reason factor for difference. Two-way ANOVA, meaning used when we study the effect of two factors on the results. Example, a teacher checks students' marks based on both teaching method, lecture, online, group discussion and gender, boys, girls. Here, the two factors is equal to teaching method plus gender. Two-way ANOVA not only checks the effect of each factor separately but also if there is a combined effect. For example, boys may perform better in online classes, while girls do better in group discussions. Use when two reasons factors may affect the outcome. Difference in simple words. One-way ANOVA is equal to one factor. Example, only teaching method. Two-way ANOVA is equal to two factors. Example, teaching method plus gender. Why important? Helps teachers, managers, and researchers understand what really influences results. Saves time instead of doing multiple t-tests. Widely used in education, business, psychology, and marketing research. Quick tip to remember. One-way is equal to one reason simple comparison. Two-way is equal to two reasons double comparison. In short, ANOVA is a powerful tool for comparing group averages. One-way ANOVA studies the effect of one factor, while two-way ANOVA studies two factors and their interaction on results. Next important long question is 4. Bivariate and multivariate statistical techniques. In business research, we often deal with data to find relationships and patterns. Depending on the number of variables we study, we use bivariate or multivariate statistical techniques. Bivariate statistical techniques. Meaning bi means two. These techniques study the relationship between two variables only. Purpose, to check if one variable affects or relates to another. Examples. Correlation, to see if advertising spend, X, is related to sales, Y. Regression, simple to predict sales, Y, based on price, X. In classroom terms, like checking if hours of study and marks are related. Easy to apply when we just want to know how two factors are linked. Multivariate statistical techniques. Meaning multi means many. These techniques involve more than two variables at the same time. Purpose, to understand complex situations where outcomes depend on many factors together. Examples. Multiple regression, predicting sales using price, advertising, and income level. Factor analysis, finding hidden patterns, like grouping customer preferences. Cluster analysis, dividing customers into groups, example, budget shoppers, premium shoppers. Discriminant analysis, classifying people into categories, example, loan approval, approve, reject based on income, credit score, occupation. In classroom terms, like checking if hours of study, sleep, and internet use together affect marks. Key difference in simple words. Bivariate is equal to simple story one cause and one effect. Multivariate is equal to complex story many causes working together for one effect. Why important? Bivariate helps in basic research when we just want to see a simple link. Multivariate is powerful for real-life business where outcomes depend on many factors at once. Quick memory tip. Bi is equal to two variables only. Multi is equal to many variables at the same time. In short, bivariate techniques study the relationship between two variables, while multivariate techniques handle multiple variables to understand complex relationships. Both are widely used in business, education, and social research. Next important long question is 5. Correlation and multiple regression analysis. In business research, we often want to know whether two or more things are connected. For this, we use correlation and multiple regression analysis. Correlation, meaning correlation shows the degree of relationship between two variables. Types: 1. Positive correlation, both increase together, example, more study hours is equal to higher marks. 2. Negative correlation, one increases, other decreases, example, higher price is equal to lower sales. 3. Zero correlation, no link, example, shoe size and intelligence. Value range from 1 to +1. +1 is equal to perfect positive relation. 1 is equal to perfect negative relation. 0 is equal to no relation. Example, in business, advertising spend and sales revenue often have positive correlation. Correlation only tells how strongly two things move together, but not cause and effect. Multiple regression analysis, meaning regression goes one step further. It tells us how much one or more independent variables affect a dependent variable. Multiple regression means studying one outcome, dependent variable, based on two or more factors. Formula, simple form. Y is equal to A plus BX plus BX plus BX. Y is equal to outcome, example, sales. X is equal to factors, example, price, advertising, income. B is equal to weights showing strength of impact. Example, in business, sales, Y, is equal to influenced by price, X, advertising, X, and customer income, X. This helps companies decide whether to cut price, increase ads, or target higher-income customers. Multiple regression not only shows relationship, but also predicts outcomes. Key difference in simple words. Correlation is equal to tells the direction and strength of the relationship, just friendship. Regression is equal to tells the actual impact and can predict results, cause-effect. Quick memory trick. Correlation is equal to connection. Regression is equal to reason plus prediction. In short, correlation shows how two variables move together, while multiple regression shows how many variables together influence an outcome and helps in prediction. Both are essential tools in business research. Next important long question is 6. Multidimensional scaling. In business research, sometimes we want to know how people feel about products, brands, or services, especially when many hidden factors like quality, price, taste, trust affect their choices. For this, researchers use multidimensional scaling, MDS. What is MDS? Definition: MDS is a statistical technique used to show the perceptions or preferences of people in a simple visual map, 2D or 3D. It helps in converting complex data into an easy-to-understand picture. It shows how similar or different things are from each other. Think of it as a Google map for products. The closer two brands are on the map, the more similar people feel they are. How it works. 1. Respondents compare brands' products, example, Pepsi versus Coke, or iPhone versus Samsung. 2. Their answers are converted into distances. 3. A map is created where close distance is equal to products are perceived as similar. Far distance is equal to products are perceived as different. Example. Suppose a company wants to study soft drink preferences. Customers compare Coke, Pepsi, Sprite, and Fanta. MDS creates a map. Coke and Pepsi are close, both cola drinks. Sprite is a little far, lemon flavor. Fanta is farthest, orange flavor. This helps the company understand competition and customer perception. Uses in business. 1. Market research identify customer preferences. 2. Brand positioning find out where your brand stands compared to competitors. 3. New product development spot gaps in the market, example, a flavor no one offers yet. 4. Customer perception study see how people group products. Easy memory trick. MDS is equal to make data simple. It simplifies customer thinking into a map. Just remember, closer is equal to similar, farther is equal to different. In short, multidimensional scaling, MDS, is like making a map of customer minds. It shows how similar or different products are, helping companies plan marketing, product design, and branding strategies effectively.